Hello. So today we're going to look on measurements 2, where we're going to look at perimeter, area, and volume of shapes. Okay. So we're going to deal with different shapes here, but what you need to note first is that you're going to be dealing with the different units here. So you must remember how to convert. So you always have to convert and you always have to convert to required measuring units. So you'll be guided which units are to use. So you still need to remember how to convert from from meters, to centimeters, to millimeters, all those things, liters to milliliters, and also kgs. You must also understand that from kgs to grams, how do you measure that, to milligrams? So these are the things that you need to remember, and you also be able to use the conversion factor that will be given in the exam. Okay. So different questions will require different approach. So that's what you need to remember. And also check on the question and see what is the required unit and convert everything to the same unit. So you'll be using same unit. Using same measuring unit. So because you might get your calculations correct, but the thing is you'll be using a different unit, and it will be a wrong answer. Now let's look at the different explanations, like terms that you need to understand. We need to understand what is perimeter. Perimeter is the distance around outside of the shape. So whatever distance that you talk about, we're talking of perimeter. So perimeter here, you don't units, it's just units. You just give them as they are. If it's centimeters, it's just if it's centimeters. If it's meters, it's just going to be meters. If it's kilometers here, it's just going to be kilometers. But now let's look at the at the area. Area measures the space inside the shape. So here now, your units, it's units squared. So unit squared, it can be centimeter squared, it can be meters squared, it can be kilometer, squared. That's what we're talking about when we're talking of area. Now, what about volume? Is the measure of space occupied by an object equal to length, breadth, and height? We're going to do some questions pertaining this. But again, here you need to remember that you have to say units. Your units, you must always cube them. So for example, it can be centimeter cubed, can be meters, cubed, can be kilometer, cubed. So this is volume. So always it's a power of 3. You put a cube on your unit. Now what is radius now? Let's have a circle here. So this is just a circle, and this one is a center. So from any distance from the center to the circumference. So we call this the circumference, and any distance from the center to the circumference is what we call radius. What about diameter? Let's look at the diameter here. When we're talking of diameter now, it's a different story now, because we are saying it's a distance from the center, from the this line through the center. Okay, that touches two sides or 2 points on the edge of the circle. So here is our diameter. So diameter has to pass through the center. So for example, here we can have a line coming from here, passing through the center, and this one here will be our radius. So we've got our radius, then we have got our diameter. And what you need to understand again here is that radius is equal to diameter divided by 2. So whenever you'll be using what called radius in most calculations, so you must understand that you always have to divide your diameter by 2 if you're given diameter. Okay. And if you're just given diameter, there's no need for you given the radius, there is no need for you to convert to diameter. Okay, let's move on to the next slide. Now let's talk of perimeter first. We're gonna look at the perimeter. So we're gonna look at perimeter and area. So this is what we call a rectangle. So a rectangle And on a rectangle, we must understand something on a rectangle. We know that two opposite sides are equal. So two opposite sides are equal. Then we are saying this side here is equal to this side here, and this side here is equal to this side here. So the longest side, we call it what called the length. So this is the length, and this one here is the width. And on the width, some of you might see what call breadth. Okay, so we can call it the breadth or width. Okay, so the longest side is always have to be is your length. Then how now do you get the perimeter? Now, how do you get the perimeter? Remember, we say this is L, this is also width. So these two sides are equal. So what do you do now to get the perimeter? Perimeter, remember, is a distance right around what called the circumference, the shape. So we're going to say, okay, how do we get perimeter? Perimeter is going to be equals to length plus what call your width here plus your width. But what do you see here? We have got 2L, we have got 2W. So it's going to be what called 2 times your length plus width. That's what we'll be having here. So we are saying is 2L plus what call your width. So this is what you need to understand. Or we can even split it and say what call 2L, which is 2 times L plus 2 times what call your width. That becomes your perimeter. What about area? Area is going to be equals to length times width. Okay, it's always length times width. Let's move on to the next what call a problem here. This one here is a square. Square, what is the property of a square? All sides are equal. All sides equal. Now, if all sides are equal, it means that this is our S, this is our S. So we can put this sign here. Oh, I made a mistake here. This shows that the two opposite sides, we can just show by 2 arrows here. But for this one here, we are having only 1, 1, 1, showing that all the sides are equal. Now, how do we get the perimeter here? Distance right around the shape is perimeter. Is going to be equals to S plus side plus side plus side. So this is side. The S is actually what called side. So we're going to say S, how many S do we have here? It's going to be 4 times side. So 4 times the side that you're having. Okay, what about the area? Area is going to be equals to side by side. And what is side by side is side squared. That's what we'll be having here. That becomes our answer. Okay, now let's look at what called the next slide here, where we're having a triangle. And how do we deal with a triangle? This is a triangle. And on a triangle, you must always know that when you are calculating our triangle, it consists of 3 sides. And how do we get the perimeter? Perimeter is going to be equals to, you're just adding the sides. So here, if you say side 1, side 2, side 3, it's going to be side 1 plus side 2 plus side 3. It's not going to be a problem that much. But let's look at the area here. How do we get the area? We're going to say this B here represents what called the base. And what about the H? Your H is your height. Okay, your H is your height. So how do you get the area? Area is going to be equals to half of the base, okay, times the perpendicular height, which is H. So the formula here will be equal to half BH. That's what we mean here. So it's half times the base here times the height. That's how you get the what called the area. Okay. Some cases you'll be given a a triangle like this, where we are having what called the height. And when you see this, this represents that's gonna be our height here. That's gonna be our base, and still we come to the same thing. Now let's look at what called a circle. So this is a circle. And remember, we have a radius. And how now do we get what called the perimeter? So perimeter is equal to 2 pi r. So 2 pi r, this is how you get what called your perimeter. But also remember here, when we say 2 pi r, it's more like we're saying 2 r pi here. So let me just say 2 r pi. But what do we know here from the 2r? We know this is our diameter. So in some cases, they can give you a diameter. So let's have a line here passing through there. That's our D. So if they can give you a diameter, we know that perimeter also, we can say it can be diameter, which is what called diameter times pi. So whatever you be given, if you're given diameter here, you know that that's how you get it. You're going to say there is no need for you to divide by 2 to get what is it, to get the R first, then you substitute. You can also say diameter times pi is going to give you also what called the same answer. What about the area? Area is equal to pi r squared. Area is equal to pi r squared, which is pi times r squared. But again here, you must know that your r is equals to d over what call d over 2. So which is diameter divided by 2. You must always remember that. And what else do you guys need to know here? We have the area, which is pi r squared. And I think that's all. Let's look on the second second slide here. Let's look at the volume. But now, before, I just want to give you an example here. Let's say this is a 3 centimeter. Then this is 7 centimeter. What is going to be our area here? Our area is going to be equals to half times the 7 times the 3. Okay, so this is what we'll be having. So we've got half times 7 times 3 is going to be 10,5. Then we have our 10,5 centimeter squared. What about if diameter here is 18 meters? It means that the radius is going to be 18 divided by 2, which is going to be 9 meters in this case. Okay, then what do we do in that case? We're going to say, what is our perimeter? Our perimeter is going to be equals to diameter. Remember, diameter times your pi, which is going to be equals to 18 times times pi. And our pi, normally you are given as 3,142, but remember, you must use the required pi that will be given. Okay, so here is going to be 3,142. So let's use that. Let's say 18 times 3,142. What do we get here? We're going to get 56,5 6 if you round off. So it's going to be 55. Is it 55 or 56? It's 56. It's 56,56 meters. Okay, so it's gonna be meters. What about if it is what is it? Our area is equals to pi r squared. And when it's pi r squared, what is our pi? 3,142 times r is 9 squared. What do we get there? So it's 3,142 times 9 squared. What do we get? We get 254,50. So it's 254,50 meter squared. Can you see that? So here it's just meters, but here it's a square. Why? Because it's area. Okay. Let's look on the let's look at volume. So here let's look on our volume. And on this volume, we have got a rectangle box. So rectangle box. And on the rectangular box, you see that we have got our length, height, and breadth, which is, we can also call it width. So how do you get the volume in this case? Volume is going to be equals to length times breadth times height. That's how you get your volume. Let's say, for example, here your breadth is 5 what call centimeters. Then your length is it's 11 centimeters. Then your height is 7 centimeters. What's going to be our volume? Our volume is going to be equals to 5. So here we can start with, let's just start with the length. So it's going to be 11 times 5 times 7. And what do we get? We're going to say 11 times 5 times 7, we get 385. So 385 is 385 centimeter cubed. Why cubed? Because it's volume. Let's look on the volume of a cylinder. So this is a cylinder. So on the cylinder here, what you must know that the surface of the cylinder is actually a circle. The surface of the cylinder is a circle, and if it's a circle, it means that we need to have the base area times height. So volume here is going to be our base, which is a circle, area times height. Now, what is our base area? Base area is pi r squared, which is area of a circle, times h. So we call it pi r squared h. That's how you get what called the volume of the cylinder. Let's say, for example, here, the radius, let's say the diameter here, from here, let me use a different color here. Let's say from this part here to this other part here, which is the diameter, is actually what you call 22. Let's say it's 22 centimeters. What are we going to be having now is that we are going to calculate what you call the radius first. So r will gonna be equals to d over 2, which is equals to 22 divided by 2, which is gonna give us 11 centimeters. But what about our height? Our height, you can be given as what you call our height. We can be given as maybe let's say also maybe 13 centimeters. What must we do in that case? We're going to say pi. Remember, pi is 3,142. Let's use pi as 3,142 times what is our r? It's 11 squared times what is our height? Is 13. Let's see what we can do here. So it's 3,142 times 11 squared times what called 13. What do we get? We get 4,942,37. So 4,942. So it's 4,942. Let me just confirm that. Okay, comma 37. We round off to decimal. Then here it's centimeter cubed because it's what called its volume. So these are the what you call formulas that you guys must remember. You must remember the formula here. Okay, you must also remember this formula of a cylinder. Okay, so let's look at the some examples, some practice questions to do. Let's attempt some questions here and see how far we can go today. Mr. Masingo is working as an intern at Bata Shoe Company in Durban. The company designs boxes and other containers for shoes. He is required to work on a design for a shoe box as shown in the diagram. So you've got a picture of the box, shoe box here, and also have the dimensions. And you can see the dimensions that you are given. You are given in what you call, you are given the dimensions in millimeters. Can you see that? You're given the dimensions in what? Millimeters. Can you see that? Always check the unit, guys. Always check the unit. Now, the dimensions of the base are the same as dimensions of the top lid. That's what we're told here. So area is equal to length times width. That's what we're told here. So we've got the area that we are told, and use the information to answer the question that follow. Determine how much cardboard the surface area is needed to make one Bata box, what call in centimeters squared. Now the shoe box is 6 faces, so you're told that the shoe box have got how many faces? 6 of them. Okay, and the overlap is not taken into account. What are these six faces that we are being told here? So the 6 faces here, we have got the top and the bottom, and remember the top and bottom are equal. The top and bottom are equal. So we're going to start with the top and bottom. But let's see here. Let's have the length. So we've got our box here. It's length. We want also your answer to be in. Let's check here. The answer must be in, before we go further, the answer must be in centimeter what called squared. Now, if it's centimeter squared, it means that we need to convert these dimensions first. So we're going to start with our length here. Let's see if we can see this. Okay, our length is 320. Remember, 320 divided by 10. Why? Because we know that one what called centimeter is equals to 10 millimeters. So we have to divide by 10 here. We are moving on to what called, so it's going to be 32. So it's 32 centimeters. Okay. Then what about our width? Our width is 205 divided by 10, which is going to be equals to what called 20,5 centimeters. What is our height? Our height is going to be equals to 111 divided by 10, which is going to be equals to 11,1 centimeters. Now we have everything in centimeters. We are able to calculate what call our areas. Now let's look at the top and bottom. What is top and bottom here? We know that is because there are two, so we're going to be saying 2 times 2. It means that we have got two sides, but what are we going to do here? Length times what call what is it? Width. That's what we know. So what is that? It's going to be 2 times what is our length here is 32 times what is our width is 20,5. Okay, what do we get as a final answer there? Let's see what we get there. Let's move that. So it's going to be 2 times 32 times 20,5. What do we get? We get 1,312. So it's 1,312 what called centimeter squared. So we've got top and bottom. We are done. Okay, let's look at the side. These two sides here. So the first what called the big side. So it's going to be 2 again because they are equal. This side and this side, they are equal. It's going to be 2 times, what is it? Your length times height. Okay. What is 2 times length times height? It's going to be 2 times 32 times height 11,1. Then what do we get? Let's punch in our calculator. It's going to be 2 times 32 times 11,1. We get let's see what we get here. 710,4 710,4 what called centimeter squared. What about the small sides? Small sides are your 2 times what is it? Width times height. So we are looking at these small sides here. That's what we're looking for. Then let's see here what we're going to get. 2 times 20,5 times 11,1. What do we get? It's going to say 2 times, okay, it's going to be 2 times 20,5 times 11,1. We get 455,1. 455,1 what we call centimeter squared. Now we are to determine how much cardboard surface area is needed to make one cardboard. So we're going to add everything here. So we know that what is going to be total surface area. So surface area, total surface area now is going to be equals to, we have got 1,312 plus 710,4 plus 450 what call 5,1. Then what do we get as a final answer? Let's look at that. It's gonna just say our answer 455, or let me not do that. 1,312 plus 710,4 plus 455,1. What do we get? We get 2,477,5. So 2,477 2.5 centimeter squared. So this is the total surface area that we are having. So how many sides are we having? 2, 4, 6. Okay, so we are done from there. So let's look at the next question. What we have. So 10 years ago, John bought a rectangular prism shaped ottoman and two matching cubic shaped ottomans. He wanted to refurbish each of them by having the sides surfaces excluding the top and bottom. Again, guys, you must always understand, take note of what they're excluding. When they say excluding top and bottom, it means only you are dealing with what called the sides. So you need to repaint, but how do you repaint? You repaint only the sides. You will also employ an upholsterer to recover the top of each ottoman and to attach cylindrical shaped legs to the base of each ottoman. Each cubic shaped ottoman will have 4 legs, while the rectangular prism shaped ottoman will have 6 legs. So always mark the keywords, highlight key things. So here we're told that here is going to be 4 legs here, but here is going to be 6 legs. Now let's look at the dimensions here. The dimensions are: length is 190 centimeters, width is 400 millimeters, and height is 400 millimeters. Can you see here? You have got centimeters, you have got millimeters. So you need to know, you now need to be prepared to convert. Let me just change this one here. I think there's a mistake here. It's 400 millimeters, okay, not 4 millimeters. Okay, so here we can see you need to prepare yourself to convert now, because you have got centimeters, you've got millimeters, and at the end of the day you need to use what call same units. Now cubic shaped ottomans, his side is 400. Now when you say cubic, all the sides are equal. Okay, so here picture of the leg, we've got picture of the leg here, diagram of a leg. You've got 75 centimeters, which is your diameter here. It's your diameter. You can see that it's covering from one end of the circle to the other. So it's touching both ends. So it's diameter. Always notice that. Then the height is 8 centimeters. Diameter and also what you call the total height. Now, ottomans, a piece of furniture like a large box with a soft top used as a seat. We all know these things. I think we've seen them, and some of us, we have them at home. Now, your faster, someone whose job is to cover furniture with material. But what is it that is important here is to start understanding questions here. Determine the total number of legs for your fastener John has to purchase. How many legs? So Tina, we're going to say for the 2.1, let me use a yellow color here. 2.1, we're going to say, okay, total number here, we've got 6 for the big rectangular ottoman, plus 4 times 2, because we are saying here each of these 2 here we have got what called 4. So this is going to be 6 plus 8, which is going to give us 6 plus 8 is what called 12. Is it 12? No, it's 14. 14 legs. Now let's look at 2.2. 2.2, calculate the radius of the ottoman. Remember, they gave you diameter. So radius is equals to diameter over 2, which is going to be equal to 75 divided by 2, which is going to give us what? 75 divided by 2. What do we get? We get 37.5. So it's 37.5. What is what is it? The unit there, 35.5 radius is centimeters. Sorry, here is millimeters. Okay, we were not told here which unit to use. We're not told any unit which unit to use. So here we're gonna just stick to the millimeters that they're giving us. That is 75 millimeters. So it's gonna be 75 divided by 2. We get 37.5. Then let's look at 2.3. Calculate in centimeters the total, remember here, they are highlighted in centimeters. So your answer must be in centimeters, meaning to say you need to convert the total height, including the legs of one cubic shaped ottoman. So here, we want to calculate the centimeters, total centimeters. Here we're going to say we want this leg here and also this height here. So we're actually looking at the total what called height here, which is going to be your 8 centimeters plus your 400 millimeters. But they say it in centimeters. So we're going to say, you're going to say the height there of height is what you call 400 divided by 10, we're going to be 40 centimeters. Then here we're going to say the total height here is going to be equals to 40 plus what is it? Not, did I make a mistake here? Yes, 40 centimeters plus the height of the leg is what is it? 8 centimeters, which is going to give us 48 what is it? Centimeters. Okay. So that's what we have there. So it's 48 centimeters. Let's look on the 2.3. That's blue comes out here. Yeah, it's comes out. So let's look at 2.4. Now, calculate in centimeters squared the surface area of the side surface of all 3 ottomans that need to be painted. You may use the formula area of a rectangle, which means this one here is a rectangle here. Rectangle. And area of a square, this side here is a square. And here is also what? A square. So let's look at the first thing that we need to do here is to classify them. Let's start with the rectangle. Area on the rectangle. So the rectangle is going to be the side, the rectangular side, the rectangular, what you call it, prism. So let's say the prism. So that's the one that we start with here. So we're going to look at the sides here. The sides of, we have got 2 of them. So it's going to be 2 times length times width. Okay, what is our length? What is our width? So we know that here 400. So 400 millimeters here is 40 centimeters. So it's 400. We have done the calculations here. So our width here is going to be 2 times, what is our length here? 190 times 40. What do we get as a final answer there? Let's see. So it's 2 times 190 times 40. We get 15,200. So it's 15,000, what we call 200 centimeters squared. Then what about what is it? The smaller sides there, which is what is it? 2 times side. We are looking at the rectangular prism, so it's going to be 2 again times side, which is going to be equals to 2 times 40 times 40, which is going to give us, let's see, 2 times 40 times 40, we get 3,200. So it's 3,200 centimeter squared. Okay, then let's look on the smaller what you call cubic shaped one. So let's look at the cubic shaped one now. Cubic shaped. Cubic shaped here, we're going to say, okay, it's how many of them? How many faces do we have? We have got 4 on each. So 1, 2, 3, 4. We've got 4 on each. And how many are there? In total, there are 8. So we've got 8 sides. So 8 times side times side. So here, what are we going to have here? It's going to be 8 times 40 times 40, because they've got 40 sides here, 40 sides here, 40 squares. That's what we have on the smaller, on the cubic one. So it's going to be 8 times 40 times 40, we get 12,800. So it's 12,800 centimeter squared. Now we have everything that we need, because we need the total surface area, what we call, of all three ottomans. Okay, that's what we need. So we are going to say, how do we get the total here? Total is going to be equals to your 15,200 plus 3,200 plus 12,800. What do we get there? Let's see. So it's 15,200 plus 3,200 plus 12,800. What do we get? 31,200. So it's 31,200. Let's say, yeah, okay. So it's going to be centimeter squared. That's what we have. That's going to be our final answer. Okay. Let's look on the next question here. John bought a 1 liter tin of luxurious silk paint to paint the side surfaces. The paint has a spread rate of 9 meters per liter. So it's 9 meters per liter. Okay. 1 liter tin of paint. This shows a 1 liter tin of paint. Now calculate in milliliters. Again here, you are guided in milliliters, the amount of paint needed to paint all the ottomans with 2 coats of paint. So you're going to have 2 coats of paint in this case, and we need to have our answer in milliliters. So what must we do first? We know that the total surface area, we have it. That needs to be painted. So total surface area to be painted is equal to, we have it in our, it's 31,200. We have it, 31,200, 31,200. What was this one here? Is square centimeters. Centimeter squared. Okay. Now, with the 31,200, we need to learn to also to converting from centimeter squared to meter squared, because we need to first get what is what call the area in this area in meters squared, so that we can check how many liters do we need, because we are told that it's 9 square meters per liter. So we need to first check the area in meter squared. So how do we get that? Or you know that from centimeter to meters, we know that what do we do here? We actually multiply by 100. No, we don't multiply by 100. We divide by 100. Okay, so since now we're saying centimeter squared, it's gonna be also divided by, we say from centimeter to centimeter squared to meter squared is also 100 squared. That's the conversion here, which is going to be just 10,000. So 100 squared is what we call 10,000. Okay, so always remember that if you are to move from centimeter cubed to kilometer to meters cubed, you also cube the conversion factor. That's what you just need to do. Okay. So in this case now, we're going to say, okay, so what is the total surface area now? TSA is going to be equals to 31,200 divided by 10,000. What do we get there? So 31,000 divided by 10,000. We're going to get 3,12 meter squared. So it's how many meters? 3,12 square meters. So now here, what are we having here is 9 square meters, 9 square meters per liter. So in this case here, we are told that it's not, sorry, so it's going to be 9 square meters per liter. So when I check how many what call liters do we need here? How many liters do we need in this case? Okay, and in this case we can convert 1 liter is equals to 1 liter is equals to what is it? How many milliliters? 1 liter is, we can convert first to what you call, milliliters. So milliliters is actually we times by 1,000. Okay, that's what we do. So it means that 9 square meters covers what called 1,000 milliliters. Okay, and what about 3,12? It needs what? Here we have our x, so we can just cross multiply there and see how much we need in what is it in milliliters. So it's going to be 9x is going to be equals to 3,1412 times 1,000. Then let's see what we can get there. We divide by 9 here, we divide everything by 9 there, we cancel. Then we're going to say your 3,12 times 1,000. Okay, what do we get there? Divided by 9. Okay, then that's what we get. We get 346,666 goes on like that. So it's 346,66. So 346,66. We can just say 667 there. That's what we have is what? Milliliters. So that's what we have there. That's needed to cover 2 quarts. Now, what is it automates with 2 quarts of paint? So if it's 2 quarts, we're going to say this answer here times 2. So the answer here is going to be 346,667 times 2. What do we get there? Let's see here. 346,667 times 2. What do we get there? We get 693 liters. So it's going to be 693 93,33 what called milliliters. Okay, that becomes our final answer like that. So I think you understand that here we have got 2 quarts, so we need to multiply by 2. We also need to first check what is the area that what call in area in meters, in centimeter squared, from centimeter squared. We also manage to do that. Now the tin is an interior is an inner radius of 3,3 centimeters. Calculate the height in centimeters of the paint in the tin if 1 liter is equals to 1,000 cubic centimeters. You may use the following formula. Height is equals to, so we've got height is equals to volume divided by 3,142 times r squared. So what is it that we need to notice here? We want to check 1 liter. We want to calculate everything here in centimeters. Okay, so we must make sure that we convert whatever, what is it, the tin has an inner radius of that. Calculate the height of the paint in the tin if 1 liter is equals to that. Okay, so here we've got 1,000 cubic what is it, centimeters as our volume. So this is our volume. This is our volume. So our volume is 1,000 cubic. So here we come back here and say, okay, how now do we get what is it, the height? Height, we are given the formula already, volume over 3,142 times r squared. What is our r? Our r is equals to what is it, is equal to 3,3. So we're going to say 1,000 over 3,142 times radius squared, which is 3,3 squared. Okay, then what do we get as an answer? So it's 1000 over 3,142 times 3,3 squared. This is what we get. We get 29,23. So it's 29,23 centimeters. That becomes our final answer like that. So it's 29,23 centimeters. That's our height. Okay, let's move on and see what we have. The next one here. Dr. Serot, the head of Maths, Science and Technology, has to produce rectangular display boards when organizing a science fair. The external dimensions of each board are 52 inch by 40 inches. The front surface of the board must be spray painted with one layer of non-reflective white paint. 1 mil of paint covers a surface area of 50 square centimeters. Then 1 inch is equals to 25 centimeters. Now use the information above to answer the questions. 3.1 is saying, determine, showing all calculations, whether 8 liters of paint would be enough to spray paint 30 display boards. The formula may be used. So area is equals to your length times your width. And we are told that the dimensions here are your 52 inches by 40 inches. Okay. Now, so what do we need to know here? We are asked to find what is it? The area, sorry, determine, showing all calculations. So we need to check here the area first. And in this case here, our area is actually given in what we call square centimeters. And we have got inches here. So we need to, we have some conversions to do here. So let's convert from inches to centimeters first. So inches to centimeters. That's what we want. So we are told already 1 inch is equals to 25 millimeters. So in this case here, we're going to what we call to get to millimeters, then from millimeters to centimeters. So it's going to be inch. According to the information that we are given, we go to millimeters, then from there we move to centimeters. So we're going to say, okay, what is the dimensions here? Our length here is what we call length is 52. Length is 52. So it's going to be 52. How do we get the from inches to U? We're going to say by 25. Then what do we get as our length here? Our length will be 52 times what we call 25. We have got 1,300. Don't forget that we are on millimeters here. Then from millimeters to centimeters, that's going to be 1,300. What we call divided by 10, which will get 130 what we call centimeters. So we have our length in done. Let's look at the width. Width is going to be equals to 40 times 25. Then what do we get here? 40 times 25, we get 1,000. So it's going to be 1,000. 1,000 what? What we call millimeters. Then from millimeters to centimeters, 1,000 divided by 10, we get 100 centimeters. So now we have got our length is 130 and our width is 100. Now we can play around with the area now. So area of 1, now area. So you can use a different color here. The area is length times width. What is our length? 130 times 100. Okay, 130 times 100 is gonna be, so 130 times 100. Just gonna add 2 zeros there. is going to be 13,000. So it's 13,000 square centimeters. Now we are told that 1 mil of paint covers surface area of what you call what is it? Surface area of 50 square centimeters. So what must we do now? We must calculate a milliliters. Okay, paint in. So we need the paint in milliliters first. So in the paint in milliliters first, since 1 mil covers 50, what about 1,300? Sorry, man, 13,000 square. So this becomes our X. So it means that you're going to say 13,000, sorry, divided by your 50. What do we get there? So it's 13,000 divided by 50. We want to get how many mils do we need? So it's 260 mils. Okay, so these are 260 mils in what you call in what is it? In milliliters. Okay, just plug in. Okay, so it's 260 milliliters for what? For how many? Just for a one. Remember, this is just for one surface. To just for what you call okay, so here remember this is just for one surface, and we need to how many boards? 30. So we have got 30 display boards here. Let's not forget that. So here we're going to say, okay, it's not a problem. We have got 260 mils that needs to cover one display board. So here is going to be 250 mils per display board. And we need this answer. We can convert this answer in liters now, or we can convert it later. But now what do we need to do first? We can multiply first and calculate the total in mils. So you're going to say 260 times how many display boards? Times 30. So this is 30 display board. So how many, what are we going to get there? 260 times 30, 7,800. So it's 7,800 mils for how many? 30 display board. So here we want our answer now in what call in liters now. How do we get that? We're going to say we know that 1 liter is equals to 1,000 mils. So here is going to be 7,800 divided by 1,000, which is going to get 7,8 liters. So these are 17 liters required. So if it's 70,8 liters required, and we are told that what is what called available is 8 liters. So 8 liters is going to be enough. So 8 liters is going to be enough. Show all calculations whether 8 liters will be enough. Yes, it will be what called paint will be enough. So 8 liter. So you can just conclude here. The 8 liter will be enough. Okay, so 8 liter will be enough because the required is 7,8. Okay, let's look on the, I think, our last question, okay, before we get to the practice. So the last question here is saying, Dr. Durant has a choice of 2 cylindrical containers as shown below for display purposes. A decorative label with a 1 centimeter overlap with a 1 centimeter overlap will be placed right around the container, completely covered the curved surface only. So here, decorative label with a 1 centimeter overlap will be placed right around what is it? The container, completely covering the curved what we call surface. Now, cylinder A and cylinder B. So we've got a diameter of 30 centimeters, height of 30 centimeters. Then here you've got the cylinder B, you've got diameter of 40 centimeters, height of 20 centimeters. Now, verify showing all calculations whether cylinder B would require less material to make the decorative label. The following formula may be used. Curved surface area of a cylinder is pi times diameter times height. Okay, so pi times diameter times height. That's what we are told to do there. So what do we do now? We're going to say, if ever we have got a diameter of 30 centimeters on this one is 30 centimeters. Okay, let's just check something here. Doctor, okay, is a 2 cylindrical, okay, a decorative display with a 1 centimeter overlap will be, yeah. So here, 1 centimeter overlap, it means what? 1 centimeter overlap. Let me see here. So 1 centimeter overlap, it means that we are going to have here, we are going to have an overlap like this. Let me show you something here. Whatever diameter is, we are saying the diameter there is fine, but we're going to have 1 centimeter here with the 30, which is the height, okay? Because remember, the overlap is an extra that we need to put in when we are wrapping. Then here we have got again a 1 centimeter that you're going to add to that overlap, and that 1 centimeter and by height of 20. So we must always remember that there is also extra area here that we need to understand. So for this one here, area of the cavity area, surface area isn't going to give us a problem. We must see that the first one, the cylinder A, on cylinder A, we know that the total surface area pi times your diameter times your height, which we can just say h there, no problem. Then what is our pi? 3,142 times, what is our d? Our d is 30. What is our height? It's also 30. What do we get there? Let's see what we get. It's going to be 3,142 times 30 times 30 times 30. Then we get 2,827,8. 2,827,8. What is it? What is this one here? Centimeter squared. But remember here, we want the total, the overlap. So the overlap, the overlap area is going to be equals to 1 centimeter times 30. So 1 centimeter times 30 is going to be equals to 30 square centimeters. So the total here for cylinder A, total is going to be equals to 2,827,8 plus 30, which is going to give us, let's see here, plus 30. We'll get 2,857,8, 2,857,8 square centimeters. Now let's look at cylinder B. Cylinder B, and on cylinder B, we're going to do the same thing. Surface area is going to be equals to pi times d times height. And what is our pi? 3,142 times what is our d? Our diameter is 40. What is our height? Is 20. Then what we get? So we're going to say 3,142 times 40 times 20. We get 2,513,6. 2,513,6 our centimeter squared. I don't know why I have to squeeze everything there. Okay, 2,513,6. But now, what is the overlap? The overlap is going to be 1 times the 20, which is that. So it's going to be the area, overlap area is going to be 20. Then total here It's going to be 2,513,6 plus 20, which is going to be, what is it? So here, plus 20, we're going to get 2,533,6, 2,533,6 centimeter squared. That's what we get there. That's going to be now verify whether cylinder B would require less material to make the decorative labels. The following formula may be used. So here it's actually correct. So we are verifying. Whether yes, it will be require yes, cylinder B require less material. Okay, so I would call to make the decoration. So that's what we have here. So now the next question here saying Dr. Seroto traveled from his office directly to the school 45 kilometers away. He traveled at an average speed of 100 kilometers per hour and arrived at the school at 11:20. Verify showing all calculations whether Dr. Seroto left his office exactly at 10:50. The following formula may be used. I want you to do this one as your homework, and you can send to me what call when you are done. If you get this one correct, just send me if you understand. Wherever you don't understand, please ask questions, open up, there's no problem. Then here, this is part of the practice work that I need submitted. So I'm going to send you this document, and you need to finish the homework and submit to me. I will give you the deadline. I will give you the deadline when you communicate. Thank you so much. Until next time.